Today we are going to learn about the graphs of sine and cosine. First, let's plot the sine curve. As you can see, the sine curve crosses at 0, 0, the origin. It has x-intercepts at pi 0 and 2 pi 0. It also has a period of 2 pi, and that is the time it takes to complete one cycle. Now, let's change the sine equation to see how the graph changes. For example, let's let y equal 3 sine x. If we change this color real quick, we can clearly see which graph is the one I just graphed, which is g of x equals 3 sine x. As you can see, this 3 causes my amplitude to increase. It stretches out my graph vertically. So I now have an amplitude of 3. Now, let's try to look at another graph of sine. So let's delete this one, and we'll look at a new one. Y equals sine of 2x minus 2 pi. We'll change the color on this one again just to see it. Now, this one changes our graph in two different ways. It moves our graph over by having a phase shift, and it also changes my period. Okay, now let's look at the cosine curve. The cosine curve has a y-intercept at 0, 1 and an x-intercept at pi over 2, 0 and 3 pi over 2, 0. Its period is also 2 pi. Now if we change the cosine function to y equals the cosine of 2x, this is going to change our function again. It doubles my period. So I have twice as many cycles as I did before in the same window. Now the last thing I'd like to change is something on the end of my equation. So let's do y equals cosine of x plus 2. Whenever I have something on the outside of my equation, I have a vertical shift. This concludes for sine and cosine.